In the ever-evolving landscapes, the enigmatic Stubblefield coils have emerged as a subject of intense curiosity and experimentation. Named after their inventor, Nathan Stubblefield, these coils stand as a testament to humanity's unyielding quest for harnessing untapped energy from the environment. This essay aims to explore the intricacies of Stubblefield coil construction, the underlying scientific principles, and recent breakthroughs in voltage enhancement through the integration of aluminum rings. Embarking on the Stubblefield coil journey. Constructing a Stubblefield coil is a meticulous endeavor, encompassing a series of deliberate steps aimed at harnessing the Earth's electromagnetic phenomena. The process begins with the careful assembly of its components, each contributing to its unique functionality. Coil construction, laying the foundation. At the core of the Stubblefield coil lies the iron rod, a fundamental component that serves as the backbone of the device. With a diameter of approximately 1.5 inches, this iron rod provides the essential structural support. Remarkably, the utilization of two parallel iron rods further amplifies the coil's performance, underlining the intricacies of its design. Insulation, preventing short circuits. To avert electrical short circuits, an insulating layer is meticulously applied to the iron core. This layer serves as a barrier, ensuring that the wire windings, which are integral to the coil's functionality, remain isolated from direct contact with the iron. This precautionary measure guarantees the smooth flow of energy and prevents unintended disruptions. Wire wrapping, precision and interaction. The intricate dance of electromagnetic interactions is facilitated through a meticulous process of wire wrapping. Iron wire and copper magnet wire are intricately wound side by side around the insulated core. This precise winding technique creates the foundation for effective galvanic and voltaic effects, the cornerstones of the coil's operation. Galvanic and voltaic marvels. The Stubblefield coil's operation is a symphony of two distinct yet interconnected phenomena, galvanic and voltaic effects. These effects underscore the coil's unique ability to harness energy from both water and the Earth's electromagnetic fields. Galvanic effect, water's secret. In the initial stages of testing, immersing the coil in water initiates the galvanic effect. This interaction, stemming from the presence of dissimilar metals and electrolytes, gives rise to a small voltage. This discovery resonates with the principles of electrochemistry and foreshadows the coil's capacity to transcend conventional energy sources. Voltaic effect, Earth's electromagnetic embrace. The true marvel of the Stubblefield coil unfolds when it is positioned underground, where it engages in a voltaic dance with the Earth's electromagnetic fields. This intricate choreography results in the generation of significantly higher currents, showcasing the potential for substantial energy capture. Pushing boundaries, aluminum rings and voltage multiplication. In the pursuit of enhancing the Stubblefield coil's performance, recent innovations involving aluminum rings have sparked remarkable advancements in voltage output. Aluminum ring revolution. The introduction of aluminum rings into the Stubblefield coil ecosystem has ushered in an era of transformative voltage enhancement. The seemingly simple act of encasing the coil with an aluminum ring has yielded astonishing results, significantly elevating the coil's voltage output. This innovative approach capitalizes on the inherent properties of aluminum, further amplifying the coil's interaction with its surroundings. Voltage variability, clues to optimization. Connecting a voltmeter to different segments of the coil has unveiled a realm of voltage variability. These distinct voltage readings provide critical insights into the coil's intricate behavior, guiding researchers towards a deeper understanding of its operation. Each connection point offers a unique glimpse into the electromagnetic symphony taking place within the coil's confines. Pioneering voltage differential. The pursuit of enhanced voltage output has led to the discovery of intriguing voltage differentials within the Stubblefield coil setup. By strategically exploring diverse connection points, researchers have unearthed a spectrum of voltage differentials, each offering a novel perspective on the coil's capabilities. The realm of Stubblefield coils and ground battery technology continues to captivate the imagination of alternative energy enthusiasts and researchers alike. From the meticulous construction process to the intricate interplay of galvanic and voltaic effects, these coils provide a tantalizing glimpse into the potential of harnessing Earth's natural electromagnetic phenomena.